Okay guys, we're beginning video 2, picking up right where we left off. Listen up guys, you need to copy down this in your notes. These are the steps to graphing a function form equation using an XY table. There's only 3 steps. And the part right here that's in parentheses, that doesn't always happen. So it could be a lot shorter. I still want you to copy all this down. So step 1 is to rewrite it in function form. Now we should know what that means. What does rewrite in function form mean? Get y by itself. Isolate y, right? Solve for y. Okay, so that's step 1. Once you get that done, then step 2, ladies and gentlemen, read this. It says make an XY table and most of the time use the inputs of 0, 1, and 2. Now, what is that going to look like? It's going to look like this. An XY table with the input 0, 1, and 2. That's what step 2 is talking about, okay? Now, but if you look at your coefficient of x and you see a fraction, then you want to use the input 0, the denominator, and 2 times the denominator, or negative denominator. Again, but if your coefficient of x, now if you think, what is coefficient? That's the number in front of x. Once you have it in function form, if your number in front of x is a fraction, then you don't want to use 0, 1, and 2. You want to use 0. That's great. 0 is still great. 0 is the best. But you also want to use the denominator, whatever the denominator is, you want to use that number, and 2 times the denominator, or maybe a negative denominator. Okay? So, for example, let's say our function form equation is y equals 1/2 x minus, let's say, 3. When you use an XY table, because you have a fraction in front of x, you do not want to use 0, 1, and 2. You want to use 0 and the denominator. What denominator do we have on this example? 2. So you want to use 0, 2, and maybe twice the denominator, which would be 4. Or maybe the negative denominator, which would be negative 2. So those are the numbers that you want to use as your inputs on an XY table if you have a fraction as the coefficient of x. Okay? So most of the time, you're going to be able to use the easy numbers 0, 1, and 2. That's if you have no fractions. But if you do have a fraction in front of x, use 0 and the denominator. Now remember, you only need 2 points. In this case, we're finding 3. It's just to feel a little more comfortable when we graph it. And down here, you could find 3, you could find 4, but you only need 2. And the final part, step 3, which you guys should be copying down right now as I explain this, is to do the math and find your outputs. And then graph the coordinates and draw your line. So, let's go through the steps. Step 1 is to make sure it's in function form. Is it in function form? Yes, y is by itself. So step 1's done for you. Step 2 is to make an XY table. And most of the time, use which numbers as inputs? 0, 1, 2. So, if I plug in 0, my input 0 right here, that's going to be 0, because anything times 0 is 0. And then plus 1, what do I get? Come on, guys. When I plug in a 0 right here for x, I want to get 0 plus 1, and my answer is 1. Yes? So I really have the coordinate 0, 1. And let me actually graph that. 0, 1 is right here. Okay? Now, the next one is the number 1. When I plug in 1, it's pretty easy. Plug it in right here. And what's negative 2 times 1? And what is negative 2 plus 1? Negative 1. Once again, maybe you want to show your work. If you're a little confused, what we're going to do here is plug in the 1, and you'll see what answer we get. When we plug in 1, it's going to say negative 2 times 1 plus 1. And when I plug in the 1 right there, I get negative 2 plus 1. And negative 2 plus 1 equals negative 1. And that's my answer. That's my output. That is why over here, for the input of 1, I got the output of -1. Are you with me?
Yes.
Okay, so let's plug in the number 2 now. When I plug in 2, what do I get? -4, and -4 plus 1, -3. So your input 2 gave you the output of -3. Now, once again, you don't need all these 3 coordinates. Like, look, I found 0, 1. If I graph 0, 1, it's right here. If I go to 1, -1, 1, -1, it's right here. And if I go to 2, -3, 1, 2, -1, 2, 3, almost down here. Let me move this up a little. 2, -3 is right here. Everybody with me? Now, if I draw my line through those 3 points, do I get a perfectly straight line? Yeah. I mean, mine's kind of crooked. But that's it. I graphed it. You only need 2 points. You only need like this one and this one. But if you find a third one and you notice that it's off the line, well, then you know you did something wrong. So we're finding 3 points just to feel a little bit more comfortable about graphing and making sure that we have a straight line with those 3 points. Are you with me? Okay. So how about you guys copy down this one on your notebook and let's go through the steps. Is it in function form? Yes. So I can move on to step 2. What's step 2? No, that's step 3. XY table. So here's my XY table. What numbers do I need to plug in for my inputs? Now I say on the steps above it says most of the time 0, 1, and 2. So right here we're not going to use 0, 1, and 2. We're going to use 0 for sure because 0 is always great because anything times 0 is 0. But instead of 1 and 2, I am going to use the denominator. And what is my denominator? 3. So I'm going to put a 3 as an input. And for another input, I could use 3, but twice. Twice 3, which is 6, right? Or maybe you don't want to use 6 because, I mean, if we look at this graph right here, 1, 2, 3, 4, 5, 6, you're off the graph. So maybe 6 isn't a good option. Maybe you want to use the negative denominator. So if this is a 3 right here, maybe you want to use -3. But those are all really good inputs to use on these function form equations that have a fraction in front of your x. So when you plug in 0, right in here, you're going to get 0 minus 2. What's 0 minus 2? -2. When you plug in 3, now it's pretty awesome when you plug in 3. The reason why we like to use the denominator is because when you do the work, 1/3 parenthesis, which is x, minus 2, when you plug in that 3 right in there, what happens with this above 3 and this 3 down here? They cancel out. So when they cancel out, what you really have, ladies and gentlemen, is 1 minus 2. And what is 1 minus 2? -1. 1 minus 2 is -1. Okay? So let's try that same thing. Up here we have 1/3 x minus 2. So let me rewrite it. 1/3 x minus 2. But this time I'm going to plug in 6. When I plug in 6 right here, I'm going to have the 1/3 times 6. What happens with the 6 and the 3? They cancel out and you get a 2 left over up on top. Yeah, you simplify. So they cancel out, you're going to have a 2 left over up on top. So what we really have is 1 times 2. So let me write that. 1 times 2 minus 2. What's 1 times 2? And what's 2 minus 2?
0.
So when you have the input 6, you get the output 0. Final step. Let me take my original equation again. 1/3 x minus 2. And let me rewrite it. 1/3 x, but my x is -3 in this last input, and then minus 2 at the very end. So the 3 cancels, but I still have 1 times -1. That's really going to be a -1. So you really have 1 times -1 minus 2. So what's 1 times -1? -1. And what's -1 minus 2? -3. Okay, so we have a bunch of coordinates, right? We have the coordinate 0, negative 2. We have the coordinate 3, negative 1. We have the coordinate 6, 0. We have the coordinate negative 3, negative 3. You don't need all these. You only need 2 of them. But we're doing all of them just so we could feel a little bit more comfortable about our graph. Whoops, hold on one second. So let's go to the graph and let's plot these points. 0, negative 2. 0, negative 2 is right there. When we go to 3, negative 1, it's right there. When we go to 6, 0, think about this. 1, 2, 3, 4, 5, 6, 0. So you're off the graph. But that's okay. You could do that dot right there, 6, 0. Negative 3, negative 3. That would be negative 3 on the x, negative 3 on the y. So you get to that dot right there. Now, as you could see, the lines, sorry about that dot, it's ugly. The line really does land on all those points. So you put arrows on it and you're done. Let's try another. Number 3, is it in function form? Is y by itself? Yes. So we jump to xy table. X, y. What do you want to plug in for x? 0, 1, and 2. Now, if you plug in 0 for x, what is it going to say? It's going to say y equals 0. So when you plug in 0, the y is 0. When you plug in 1, the y is 1. When you plug in 2, the y is 2. And that makes total sense because x really does equal y. So whatever you plug in for x, you're going to get out for y. So those coordinates, 0, 0, right here, 1, 1, right there, 2, 2, right there, negative 1, negative 1's right there, negative 2, negative 2's right there. You only need a couple of points, but you already know that your graph is going to be that line right there. Moving on. This guy is definitely not in function form, so what do I need to do first? Subtract 8 and subtract 8. So my new equation will be 2y equals x minus 8. So now I need to divide by 2 and divide by 2 and divide by 2. So my function form equation that has y by itself will be y equals, now there is an invisible 1 right here in front of the x. So I'm going to write that as 1/2 x with the x on the side. Okay? And then we have the negative 8 divided by 2. That's going to be a minus 4 or a negative 4. Ladies and gentlemen, this is step 1, writing your function form equation. Once you have a function form equation, you want to jump to graphing with the xy table. And the inputs that we're going to use on this guy are going to be what? 0, 2, and 4. Or 0, 2, and negative 2. But right here, 0, 2, and 4 work. Okay? So if I were to, and let me show my work here, plug in 0, you're going to have y equals 1/2 times x, which is going to be 0 minus 4. If I plug in 0 right there, what's my answer going to be? What is 1/2 times 0? And what's 0 minus 4? So you get a minus 4 when you plug in 0. What if I were to plug in 2? Check it out. I'm going to have 1/2 times 2 minus 4. What happens with those 2's? Cancel out. So I have 1 take away 4. What's 1 take away 4? Negative 3 as an output. And finally, last but not least, if we have a 1/2 times 4 minus 4, the 4 and the 2 cancel out. You have a 2. So you really have 1 times 2, which is 2, minus 4. That's going to be a negative 2. And if you graph those guys, you will get a straight line. So 0, negative 4 is right here. 2, negative 3 is right here. And 4, negative 2 is right there. As you can see, all 3 dots line up perfectly on that line, and that's our graph.